Space is vast. It stretches out in all directions, seemingly infinite and filled with countless wonders. From the smallest particles to the largest galaxies, the universe is a place of endless fascination and mystery. It is full of mystery. Among these mysteries, one of the most intriguing and enigmatic phenomena is the black hole. These cosmic giants captivate the imagination and challenge our understanding of physics. One of the most fascinating objects is a black hole. These regions of space are where gravity reigns supreme, pulling in everything that comes too close. They are the ultimate cosmic vacuum cleaners, devouring matter and energy. Imagine a place where gravity is incredibly strong, so strong that it can bend light, warp space, and even alter the flow of time. This is the realm of the black hole, a place where the laws of physics as we know them break down, so strong that nothing, not even light, can escape. This is why black holes appear black. They trap everything, including light, within their event horizon, the point of no return. This is a black hole, a cosmic abyss. A place where the gravitational pull is so intense that it swallows everything in its vicinity. But black holes are not just empty voids, they are regions of immense density and energy. Black holes are not empty spaces. They are formed from the remnants of massive stars that have collapsed under their own gravity. This collapse creates a singularity, a point of infinite density at the center of the black hole. They are regions of immense density. Imagine the entire mass of a star like our sun, squeezed into a tiny, incredibly dense point. This is what gives black holes their extraordinary gravitational pull. Imagine the entire mass of our sun squeezed into a tiny ball. This is the reality of a black hole. The immense gravitational force of this tiny point can warp space and time around it. This is the reality of a black hole. Black holes are invisible. We cannot see them directly because they do not emit light. Instead, we detect them by observing the effects of their gravity on nearby stars and gas. Their gravity is so strong that they warp the fabric of spacetime. This warping creates gravitational waves, ripples in spacetime that we can detect with sensitive instruments. This warping bends light around them, making them appear black. The light that passes close to a black hole is bent and twisted, creating a phenomenon known as gravitational lensing. This effect allows us to study black holes and understand their properties. Stars are giant balls of burning gas, composed primarily of hydrogen and helium. These celestial bodies are the powerhouses of the universe, generating light and heat through the process of nuclear fusion. They shine brightly, fueled by nuclear fusion, where hydrogen atoms fuse to form helium, releasing immense energy. This energy is what makes stars visible across vast distances in space. But stars have a life cycle, much like living organisms. They are born from clouds of gas and dust, live for millions to billions of years, and eventually meet their end. They are born, they live, and they die. The life cycle of a star is a fascinating journey, starting from a nebula, progressing through stages like the main sequence and ending in dramatic events. When a massive star runs out of fuel, it can no longer support itself against its own gravity. The core collapses inward, leading to a catastrophic chain of events. This collapse triggers a supernova explosion, one of the most powerful and luminous events in the universe. The outer layers of the star are ejected into space, creating a spectacular display. The remaining core, if massive enough, continues to collapse under its own gravity. This process is relentless and unstoppable, leading to the formation of an incredibly dense object. It squeezes into an infinitely small point, where the gravitational pull becomes so strong that not even light can escape. This point is known as a singularity. This point is called a singularity, a place where the laws of physics as we know them break down. The singularity is surrounded by an event horizon, the boundary beyond which nothing can return. It marks the birth of a black hole, a region in space with a gravitational field so intense that it warps the fabric of spacetime itself. Black holes are among the most mysterious and fascinating objects in the cosmos, continuing to intrigue scientists and astronomers alike. Imagine approaching a black hole. It's a journey into the unknown, a voyage that defies the very fabric of space and time. As you draw nearer, the environment around you begins to change in ways that are both fascinating and terrifying. As you get closer, the pull of gravity grows stronger. This gravitational force is unlike anything you've ever experienced. It's so intense that it starts to stretch and distort everything around it, including light itself. This phenomenon is known as gravitational lensing, where the black hole bends light from stars and galaxies behind it, creating a warped and magnified view. Eventually you reach a point of no return. This boundary is not a physical surface, but an invisible threshold. Once crossed, escape becomes impossible, even for light. This point is called the event horizon. It marks the edge of the black hole, beyond which nothing can return. The event horizon is a critical concept in understanding black holes, as it defines the region where the gravitational pull becomes so strong that not even light can escape. Once you cross the event horizon, there is no escape. The laws of physics as we know them cease to apply in the same way. Time and space become intertwined in a manner that defies our everyday experiences. You are pulled towards the singularity. This is the core of the black hole, where all its mass is concentrated. The journey to the singularity is a one-way trip, as the gravitational forces become infinitely strong. The singularity is the heart of the black hole. It is a place where the curvature of space-time becomes infinite, and the known laws of physics break down. The singularity represents a point of infinite density and zero volume. It is a point of infinite density. Here the gravitational forces are so extreme that they crush all matter into an infinitely small space. This concept challenges our understanding of the universe and raises questions about the nature of reality itself. Around a black hole, matter can form a swirling disk. This disk is made up of gas, dust, and other debris that have been captured by the black hole's gravity. As this matter spirals inward, it forms a structure known as the accretion disk. This is called the accretion disk. The accretion disk is one of the most striking features of a black hole, often glowing brightly as the matter within it heats up due to friction and gravitational forces. The matter in the accretion disk heats up. As it gets closer to the event horizon, the temperatures can reach millions of degrees. This intense heat causes the matter to emit radiation across the electromagnetic spectrum. It emits X-rays as it spirals towards the event horizon. These X-rays can be detected by telescopes, providing valuable information about the properties of the black hole and the behavior of matter in extreme gravitational fields. The study of these emissions helps astronomers understand the complex processes occurring in and around black holes. Black holes are not entirely black. In 1974, Stephen Hawking proposed a revolutionary theory. He suggested that black holes emit radiation. This radiation, known as Hawking radiation, arises from quantum effects near the event horizon. It is a faint but steady stream of particles. Hawking radiation causes black holes to slowly lose mass over time. This evaporation process takes an incredibly long time, but it suggests that black holes are not eternal. Section 5: Black Holes and Galaxies, a Cosmic Dance. Black holes play a crucial role in the evolution of galaxies. Most galaxies, including our own Milky Way, harbor a supermassive black hole at their center. These supermassive black holes have millions or even billions of times the mass of our Sun. Their immense gravity influences the orbits of stars and gas clouds. The interaction between black holes and galaxies is a delicate dance. It shapes the structure and evolution of these cosmic giants. At the heart of our galaxy lies a sleeping giant, a supermassive black hole, millions of times heavier than our Sun. This behemoth, Sagittarius A*, is shrouded in mystery. These supermassive black holes are not cosmic vacuum cleaners. They do not consume everything in their path. Instead, they act as gravitational anchors. Their gravity holds galaxies together. It influences the birth of stars and the motion of gas clouds. Supermassive black holes are essential to the structure of our universe. Black holes warp not only space but also time. Time slows down as you approach a black hole. This effect, known as time dilation, is a consequence of Einstein's theory of general relativity. Some theories suggest that black holes could be connected to other parts of the universe. These connections, called wormholes, are theoretical tunnels through spacetime. While wormholes remain speculative, they capture the imagination. They offer tantalizing possibilities for interstellar travel and understanding the fabric of reality. Black holes are invisible to telescopes, but we can detect their presence through their effects on surrounding matter. As matter falls into a black hole, it heats up and emits radiation. This radiation, in the form of X-rays, can be detected by space telescopes. By studying these emissions, astronomers can map the structure and behavior of black holes. These observations provide insights into the extreme physics at play. Black holes, once considered celestial oddities, are now recognized as fundamental components of our universe. They are engines of creation and destruction. From the birth of stars to the evolution of galaxies, black holes play a vital role. They challenge our understanding of gravity, space, and time. As we continue to explore the cosmos, black holes beckon us. They remind us of the mysteries that still abound in the universe's grand design.